And then when it comes to graphing systems of equations and inequalities, you graph systems the same way, whether it's an equation or an inequality. For equations, the intersection of the two lines is the solution. For the inequalities, the place where the shading for both equations overlap is the solution. So for this one, I'm graphing equations, obviously, because I have equal signs, versus graphing inequalities over here. I'll do this in two different colors. I'll do this color green, this equation green. So I'm graphing my y-intercept at 1, where it crosses the y-axis. My slope is a positive 2 over 1, so I'm going to go up 2 and right 1. For the sake of not having a straight edge, I'm just making more of my slope. Rise up 2 over 1, up 2 over 1, up 2 over 1. So each point should follow the same slope. And there is my first equation. And my second one is going to be in blue. Same thing, if you don't see a y-intercept, it is understood to be a 0. So I'm going to graph my y-intercept through the origin. And that slope, that is a 1x. So you can put the 1 right there to remind you that it is 1 over 1. Let that focus. There it goes, 1 over 1. So from my origin, I go up 1 over 1. And as long as you do this on a piece of graph paper, 2 points is enough to create a line, but for the sake of not having graph paper and having one hand tethered to my phone, I am creating a bunch of points so I have that outline to follow to create my line. And this point right here is where they intersect, so that is my solution. What this means is when x is -1 and when y is -1, when you plug that into both equations, it satisfies both and creates two true statements. So just for kind of reiteration of what that means, if I tried this one and used the point -1, -1, 2 times -1 is a -2 plus 1 is -1, and that does equal -1, so that one is true. And obviously -1 equals -1, that is also true. And then the inequalities are the same. I'm actually going to graph these in yellow and green, or yellow and blue. I like to do 2 primary colors so that they create a secondary color, which ends up being your solution. So you'll see where they overlap. I'm going to graph these the same way. The blue graph, I'm going to start at the y-intercept. Slope of positive 2 over 1. Down to and it's pretty self-explanatory to go up 2 and right 1. Then you would have to go down 2 and left 1. If you went down 2 and right 1, it's going to create a V shape and not a line. So you have to kind of think about it going like that. But anyway, obviously I'm creating the line. Since this is a strictly greater than, I know this one has to be dashed. And I know I'm shading up. So I'm going to dash this, making sure this line is not solid. And this one gets shading up here. I'm shading everywhere above that line. As for my yellow equation, y-intercept at 0, 2. I have a negative slope, so I know this one's got to go down. I rise up 1, 2, 3, and I'm going to go to the left 4. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. This one is going to be solid, and I'm shading this one down. Sorry. Can't hold the paper down. Next time I'll remember to like tape the paper to the table. And shade this one down. And you can see the part that is blue and yellow is right here. So all of this area is the solution. So everything from this solid line to this side of the dashed line. The dashed line is not included in the solution, but this solid line is. This area this entire area minus the dashed line. Or I guess you could say left to get more specific. Is the solution. If they were two solid lines, then yeah, that line would be included in the solution.